Hey guys, today I'm going to do some examples from lesson 7.1, which was adding and subtracting polynomials. So what you want to remember with adding and subtracting polynomials is that you can only add or subtract things that have exactly the same variables with exactly the same exponents. So you have like x to the third and a y. You can't have x and a y to the third. They both have to have like x3 then the y. So they'd have to be exactly the same variables with exactly the same exponents. Then you can add those together and you add the coefficients up and you leave the exponents alone. The other things we did with these was naming the degree, and the degree is the term that has the exponents with the highest sum. So each term, and a term is separated by a plus or a minus sign, each term you look at the variables and you look at what the exponents on the variables are. If a variable doesn't have an exponent, then you can put a little 1 there. It has an exponent of 1. There is one of those variable there. And then you add all the exponents on the variables, and whichever term in that polynomial has the highest sum of exponents, that's the degree of that whole polynomial. It should already be in order from the greatest exponents to the least exponents, which means it would be the very first term in the polynomial, as long as it's in the right order. So, I think that was everything. If not, I'll explain it as we get through it. All right, this one, name each polynomial, page 266. Name each polynomial based on its degree and number of terms. So here, remember, we're just looking at the variables. So we have one term here, and there's just an x. So remember, x has an exponent of 1. So my degree is 1. And the number of terms is 2. Because there's 1, 2. The constant is considered a term. All right, and then we have 1, 2, 3 terms. And this has an exponent of 3. This one has an exponent of 2. So my degree is 3, and my terms are 3. Write each polynomial in standard form. So like I said, that goes from the greatest exponent to the least exponent. And I don't think, none of these have extra variables, but if they did, once you put them in order from greatest to least with the exponents, then you put them in alphabetical order. So like if they have the same degree, then the one with the earlier letter goes in front of it. All right, so this goes first, and I'm going to bring that minus sign in front of it. Remember, I say minus and negative are the same thing. It goes with that y squared. And then I'm going to put the 2y, which is positive, and then minus 3 at the end. Your constants always go at the end. All right, this one, we have an x to the third is the highest exponent. It's a little weird to see with the pen on the other side of the paper. So x cubed plus 3x squared minus 2x plus 6. Okay, and then we've got a little bit of adding and subtracting, and then I'm also even going to do one of these with the, it should be, oh, it's surface area. That one's a little tricky. I don't know the formula for surface area. Okay, we'll figure that out in a minute. All right, so when we're adding these, remember, the plus sign means these are just going to stay, we can just add everything. So you don't need to worry about what the signs are in here. Just x squared and a 2x squared is 3x squared. 2x and a negative 5x make negative 3x. Negative 4 and negative 3 make negative 7. The next example is subtraction though, so that's a little bit different. So when we have subtraction, it's like you're taking a negative 1 and multiplying each of these by that. So they made this negative, and then each of these are negative. So really, they're all going to just turn into positive. If it helps you think about it, like multiply everything by negative 1, it would just turn everything plus. So now we can do 3x plus 4x. 3x squared and 4x squared make 7x squared. Negative 5x and positive 2x make negative 3x. And negative 8 and positive 1 make negative 7. Another way you could do this, some people like to go 3x squared minus 5x minus 8 plus 4x squared plus 2x plus 1, and just stack them like that. And if that helps you to see how to do it, I mean, you're going to get the same answer. You're just writing it a little bit differently. And then you'd get 7x squared plus negative 3x minus 7. Same answer. Okay, now let me think. A square prism has square sides with area x squared plus 8x plus 16, and rectangular sides with area 2x squared plus 15x plus 28. What expression represents the surface area of the square prism? Oh, okay. So surface area, they gave us the area of each of the surfaces. So what we need to do is think about what a square prism looks like. It says it's got rectangular sides, but it's a square prism, so it's rectangular on the sides and then square on the ends. Oops, that looks a little weird. Okay. All right, so we have 2 square sides, and then 4 rectangular sides. So that means that you need to do 2 of these and 4 of these and add them all together, and that would give you the total surface area. So it might be a little easier to just multiply it first. So 2 times the x squared plus 8x plus 16, and then we'll do 4 times 2x squared plus 15x plus 28. So 2 times x squared is 2x squared. 2 times 8x is 16x. 2 times 16 is 32. So there is the sum of the 2 square sides. And then 4 times 2x squared is 8x squared. 4 times 15x is 60x. 4 times 28, 80 and 32 is 112. There we go. So then we know both the square sides and all 4 of the rectangular sides. So then I take these 2 and I'm going to add them together. So that would give me, let's see, 2x squared and 8x squared. You know, I'm just going to write the answer over here because I'm going to run out of, it's going to be all crazy there. 2x squared plus 8x squared gives me 10x squared. 16x and 60x gives me 76x. 32 and 112 gives me 144. All right. So that's a lot of steps, and it's really, you got to think about the process and think about what these shapes look like. So for instance, when they ask you to find the perimeter of the rectangle, you know, perimeter's all the way around. So you're just adding all the sides. Both of these sides are the same. Both of these sides are the same. A cube has square sides with area x squared, da 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 da. The surface area would be, you know, a cube has 6 sides, and all of those are going to have this area. So you could actually add them together 6 times, or you could just multiply everything by 6. And then, see, I don't remember which ones I gave you guys. Oh, you know what? I know we did this one, though. The perimeters of these are equal, and you go to find that one. So add all of these, subtract the 2 you know, to see what you got left, okay? And I think you had to do this one too. What expression represents the area of the new combined open space? So they're knocking down the wall between the kitchen and the family room. So we want to see what the total area is. So we're just going to add those together. I'm pretty sure that was it for this lesson. If you guys get stuck on anything, make sure you reach out.